Hello everyone, hope you all are doing well. So in this video we'll discuss the third problem of Leetcode Weekly contest here in 24. It's a hard level problem and much better than the other level 3 problems that you get. Generally you get a medium level problem, but this one is a hard one. So the problem name is add edges to make degrees of all nodes even. Okay, so there is an undirected graph consisting of n nodes numbered from 1 to n. You are given the integer n and a 2D array edges where edges of I equals to ai comma bi. That represents that there is an edge between nodes ai and bi. Now the graph can be disconnected. Okay, so you can add at most 2 additional edges, obviously possibly none, to this graph so that there are no repeated edges and no self loops. Okay, return true if it is possible to make the degree of each node in the graph even, otherwise return false. Okay, the degree of a node is the number of edges connected to it. So yeah, big problem statement, but the crux is you are given so you are given a graph. Now n is the number of nodes that you have in your graph, and edges is the this represents the nodes that are connected, all the edges in your graph, right? Now what we need to do is we need to add some edges, possibly zero, right? Like if the graph is valid, return true, or else at most you can add 2 additional edges such that the graph does not contain any repeated edges and no self loops. Okay, and basically every node has a degree of 2. Sorry, not 2 or even, right? Return true if it is possible to make the degree of each node in the graph even, otherwise return false. So let's look into some examples. So this is one of the graph that you have. Okay, now just see here, if what is the degree of 1? So 1 and 2. So for 1 it's 2. What about 4? 1 2 3. Okay, what about 3? It's 2. What about 2? 1 2 3 4. What about 5? It's 1. So just see, this is done, this is done, this is done. These three nodes have even degree. What about this 4 and 5? So there are two nodes having odd degree, that is 4 and 5. So if I connect these two as represented here, so you can see now every node has degree even. Also there are no self loops. Okay, there are no self loops here. Okay, yeah, this is one of the things. Let's look into another example. So again here we have a graph. So you can see here, 1 has 1, 2 is 1, 3 is 1, 4 is 1. So everyone has odd degree. Now what we can do, if we connect these two, so 1 will have degree 2, 3 will have 2. These two are sorted. What about 2 and 4? Connect 2 and 4. These two are also sorted. So yes, I can perform this operation. What about this one? Right, so 1 has in degree 3, 2 has 1, 3 has 1, and 4 has also 1. Now if you look into this, so 1 has 1 2 3, this is 1 1 1. Yeah, so if you look into this, there are all the 4 nodes have odd edges, so that means odd degree, so that means you need to add 2 edge. Now let's see whether adding 2 edges will solve our problem or not, right? So suppose I add 1 edge here, right? Suppose I add 1 edge here. So what will happen? 2 will have degree of 2, 3 will also have 2. These two are sorted. What about 1 and 4? So just see, to sort out 1 and 4 I'll have to add an edge here, but this will be a self loop. So that means I cannot add an edge here, right? It says na you need to avoid self loops. Just see, self loops. What is the another option? Another option is basically you connect, suppose these two. If you connect these two, so the remaining 2 nodes again you cannot connect it, otherwise again this will be again a self loop. So any possible combination you pick, it will result into a self loop, so you return false in this case, right? So I hope the problem is clear now. Now let me directly tell you what will be the intuition behind this one, right? So we saw here that we need to deal with the degree of each node, right? So first calculate the degree of each node, right? First calculate the degree of each node. Now how many edges can we add? We can add either 0 edge, 1 edge, or 2 edge, right? So once you calculate the degree of each node, what is degree? That means by that each node is connected to how many edges. Once you calculate it, so suppose the number of nodes having odd degree is 0. So that means I do not need to add any edge, right? The graph is valid. So you just return true in that case, right? We'll be done with that, right? So that means everyone has even. So we are sorted. Now, if two nodes are there, if there are two nodes which have odd degree, right? Which have odd degree. So in this case, what we can do, we can connect them by an edge. But there is a tricky case as we saw here. What if these two nodes were already connected? So that will result into a self loop. So what we can do, can there be a case that these two nodes have odd degree and I pick up a third node which is not connected with these two, right? So it says the graph can be disconnected. Suppose this is one part of the graph, this is another part of the graph. So if I connect these like this is a third node. Any node you can pick, right? Any node you can pick. So connect these two. Now what will happen? This will become a valid case. So that means in case you have two nodes with odd degree, so connect those two if those two are already not connected, or else pick up a third node and connect it with that third node, right? What about fourth one? What about the another case? Now if I have four nodes having odd degree, so what we can do, right? So similar to the case we did here, the only thing that will left is try all possible combinations, right? Try to connect these two and these two, or these two and these two, these two and these two. So how many combinations will be there? Suppose I have node A, B, C and D. So try connecting AB. So obviously I'll be left with connecting CD. Try connecting AC, so I'll be left with connecting BD. Try connecting AD, so I'll be left with connecting CB. These are the three combinations. If any of these three satisfy your condition, right? What is that condition? Again, the one that we applied in this one. That if I connect these two, then I'll connect on these two only if these two are already not connected. And also I'll do the same thing for CD. So if any of these pairs satisfy, I return true, or else I return false, right? Basic stuff. Now what about the other conditions? Other conditions can be, so I saw that if I have 0, 2 and 4 odd degree nodes, the number of nodes having odd degrees, suppose 0, 2 and 4, then I have a solution. However, if the number of nodes having odd degrees other than these three values, suppose 1, 3, 5, 6, something like this, so in that case I can return false, because in that case it will not be possible for me to make it a valid graph, right? Let's look into the code. This is the intuition behind it, right? So this is a vector which has the in degree of each and every node, and this is an adjacency list, right? What I have done here, this is an edge. I increment the degree of these two nodes, and I also basically keep a track that whether nodes A and B or U and V are connected or not. This I am doing it for checking these conditions, right? So this is a bookkeeping that I'll be doing. Okay. Now this is the odd edges that I'll be having. So what I'll do, I'll run a loop for all the nodes and I'll check if the degree of the current node is odd, then add it to your this vector, right? Now if the number of nodes, that means if my vector has a size of 0, that means every node has an even degree, just return true, right? Or else what you will do, you will check for, if it is 2, then do some processing. If it is 4, do some processing, else return false, right? Now let's see what are the processing things that we'll be doing. So pick up the two nodes that have odd degree. Okay. Now what you do, you check that if these two nodes do not have an edge, right? Do not have an edge, then you can return true, because if these two nodes do not have an edge, I can directly connect them, right? So I return true. But if these two have an edge, so I need to find a third node such that these two are not connected, then only I'll be able to connect this edge and this edge. Okay. So what I'm doing, check for a possibility of all the nodes, right? If I equals to A or I equals to B, just continue, right? I need to find another node, right? So if there is not an edge between I and A, and there is not an edge between I and B, so that means now I can connect. I found out my third node, so just return true. However, if that was not possible, so you return false. When it will not be possible, so it will not be possible by this. Suppose this is there, this was my graph, so it is not possible, right? These are connected only. Now comes the case for the number of nodes with odd degree is 4. So what you do, these are the 4 nodes, do exactly the same stuff, right? That if A and B doesn't have an edge and C and D doesn't have an edge, return true. If A and C doesn't have an edge, and similarly B and D, so these are the 3 possible combinations that I was telling you, right? So return true if any of them is satisfying your condition, or else return false, right? So yeah, that's it for this problem. I would say the trick in this problem was coming up with the intuition that only 0, 2 and 4 will be our satisfactory conditions, and that for in case of 2 you cannot bluntly connect two nodes. You need to check whether these two are already connected or not, right? So this was the main trick in this problem, I would say. So yeah, that's it for this problem. If you like the solution, do support it by giving up a thumbs up. Do subscribe to the channel. In case of any queries, do let me know. I'll revert on each one of them. Thank you. Take care. Bye bye.